Oh, sir, I sent you the thing.
Oh, you sent it to me?
Yes, sir.
All right, so I'll check it after class.
Okay.
All right, so this is 2015. Can we see the screen?
Yes, sir.
All right, just let me zoom in. It's 2015 now. All right, so 2015. The first question is a repeat. What's the first question?
Wait, sir, it's kind of blurry. When you focus first, I'll get to it.
It's blurry?
Yeah, from my screen. Come on.
The screen is, all right, let me see. Is this better?
Yes, sir.
All right, so this question is saying, what is a to the fifth minus b to the fifth? Just tell me the answer.
B.
Repeat.
B. Beta. Sorry.
Beta. Everybody agree? It is beta indeed. So just have to remember the formula a to the n minus b to the n. A to the n minus b to the n is a minus b times a to the n minus 1, a to the n minus 1 plus a to the n minus 2 times b. And then we decrease the power of a and increase the power of b till we end up get plus a to the 1 times b to the n minus 2 plus b to the n minus 1. Just to remember the general formula of a to the n minus b to the n. All right, now look at question 2. For the first time, they have not repeated. Generally, they normally put the same one, the same cubic, but this year they decided to change it.
Yes, sir. Really?
For some reason, they decided to change it this year. And so this question, they said the remainder is 3 when divided by x minus 1. And so what they're telling us is that f of 1 is equal to 3. And so plug in 1 right here to get 8 times 1 plus 4 plus k is equal to 3. And so they're telling us that 12 plus k is equal to 3. If 12 plus k equal to 3, then k must equal to negative 9. That's beta. So this is a new question. All right? That's a new question. Normally they would give you one where the answer is negative 11. And look how them smart, you know, they put negative 11. So this answer is known as the distractor. For people that are swatting, and they're just gonna put negative 11. That's known as a distractor. That's a new question. This is the first this question is coming. All right, question 3. Talk to me now. Question 3 is a big repeat. What's question 3?
Kramer, sorry.
Kramer, very good. So they tell us that 3 roots of the cubic equation. So first and foremost, we can factorize this cubic. And so 2x cubed plus 3x minus 5x minus 6. You can always factorize it as 3 linear factors. And the 3 linear factors, well, they told us x equal 1 is a root, and so x plus 1 is a factor. They told us x equal minus 2 is a root, and so x plus 2 is a factor. And so the next linear factor is 2x And in order for this to be 6, it has to be 2 times 1 times -3. And so what we're getting is that 2x is equal to 3. And so x is equal to 3 over 2. So x equal 3 over 2 is Kramer. Question 4. It gave us 4 root x plus 4 root 3x over root 48. This is a repeat. What's question 4?
Question 4 is, oh yeah, alpha.
Alpha. Very good. So just to refresh our memory, this would have been 4 root x plus, now we have to write this as 4 times the root of 3 times the root of x over, now the root of 48, I can write that as the root of 16 times the root of 3. And so the root of 3 cancel the root of 3. 4 cancel the root of 16. And so I left back with 4 root x plus root x. 4 root x plus root x is 5 root x. So that's question 4. Easy stuff, soft, the capital T. Easy like Sunday morning. Question 5. Question 5 now. This is a new question. Agreed?
Question 5, no, well, yeah, but
Yeah, it's a new question.
yeah, I
So
did
just
it.
have apply rules of logs.
Yeah, you're supposed to get alpha.
Alpha is the answer. This is a new question, but just apply the rules of log. So bring it up to get. The first one can be written as log to base 2 of 2q all cubed. Then you write minus log to base 2 of 3q squared. That part, when you group this part together, you're going to get log the base 2 of, now 2q cubed is 8q cubed divided by 3q squared is 9q squared. And then this part that tells us 1, you can write 1 as plus log to base 2 of 2. And so writing it as 1 log now is 2 times 8 is 16. So get log to base 2 of 8q cubed times 2 is 16q cubed over 9q squared. (16q cubed over 9q squared). And 16q cubed over 9q squared, that's 16q over 9, which is alpha. All right. Question 6 is a repeat. Talk to me. What's question 6?
Beta.
Beta. Yes, that's true. And so how you test this is test that f of 1 is going to give you 0. If you have to follow in our factors, f of 1 is going to give you 0, and f of -2 is going to give you 0.
Yeah, if it's plug, you can just plug it to the calculator.
Just plug it in a calculator.
Yes, sir.
So 4 plus 8 minus 2 minus 6 minus 4, that is 0. When x is -2, it gets in -2 to the 4th, that is 16 times 4 is 64, minus 2 cubed times 8, that's -64. 64 minus 64 is 0. Then you have -2 times minus 2 squared, that is negative 8, negative 8 minus positive minus 12, that becomes positive 4, and then 4 minus 4 is 0. And so beta is the answer. 2 and 3 is correct. So that's all you're testing. F of 1 to be 0 and f of minus 2 to be 0. Question 7. It says the annual population growth is represented by a function where x is years, and find out when this function is going to be equal to 32. They're asking you to solve 2x equal to 32 to find the number of years that it's going to take to reach 32. So what is x?
5.
X is 5. Which is Kramer. Easy question. Question 8. It says the general quadratic with roots alpha and beta may be written as. So we have to remember it can be written as x squared minus the sum of the two roots plus the product of their root equals 0. And so x squared minus alpha plus beta plus alpha beta, and so it is beta is the answer. Easy, soft. All right, question 9. Question 9 is asking which of the following is the inverse. It says g of x is the inverse of f of x. Which one is correct? Is A the answer?
No, sir.
B?
No, sir.
C?
Yes.
All right, C is the answer. And the reason being is that the inverse is a reflection in the line y equal to x. If you were to draw a line y equal to x, you can see that there are reflection in this line. And so therefore C is the answer. If you look at every other option, not a reflection. If you draw the line y equal to x in any other option, you're not going to get the answer. You're not going to see that mirror. And as Asani said last week, this one is a reflection in the line y equal to minus x, which is not the inverse. Question 10. The statement is logically equivalent to, this is a repeat from last week. What is this?
10, it is, yeah, we did that. It is Kramer.
Kramer. All right, so let's work it out again. Right here, we're getting the negation of, this part you can use distribution law to get P or not P, P or not P, and this part is going to be P or P and P or Q. So that's what we're going to get. Now, P or not P is always true. And so we're going to get true and P or Q. Now look at this. P or Q is going to be the result of true and P or Q. Because if P or Q is true, then true and true is true. But if P or Q is false, then true and P or Q is false. And so the result is dependent on P or Q. And so it's the negation of P or Q. And the negation of P or Q is not P and not Q. So that's not P and not Q. That's Kramer. So that's question 10. Easy stuff. Question 11. It says, which of the following statements is true? Which of the following statements is true? Dog. All right. I love that you never forget that one. Dog. The reason why this is so delta is true because the sum from 1 or the sum from 0 doesn't affect anything. So if you were to look at the sum from 1, it would just be 1 square plus 2 square all the way up to when n equal r, which is plus n square. That's going to be equal to, if you start from 0, you have 0 square plus 1 square plus 2 square all the way up to n square. But 0 square is not a value. And so we get that delta is true. Question 12.
0. Kramer.
You sure a 0?
Yes, sir.
All right. So that is true. It is 0. So working this out, it's going to be the log of, we're going to have to put it as 1 log. So it's going to be 15 minus 6 is 15 over 6. Then we're adding it to plus this half log 4 over 5 can be written as the log of 4 to the half power over 5 to the half power, because we just bring up the power, not 25 to the half power. 4 to the half power is 2, and 5 to the half power is 5. So we get the log of 4 to the half is 2 over 5. And so we have the log of 5 over 16 plus the log of, that this shouldn't be 16, it should be 6. My mistake. Yeah. That should be 6. So it's a log of 5, log of 15 over 6. So this works out to be the log of 15 times 2 is 30. 6 times 5 is 30. The log of 30 over 30 is 1. The log of 1 is 0. So Kramer is correct. All right. That's good.
Can I get the answers for 3 to 6?
3 to 6? Yes. Give me a second.
What?
All right, so scroll up. Go back on this page. 3 to 6 is, question 3 is Kramer. Question 4 is alpha. Question 5 is alpha. And question 6 is beta. That's good?
Mm.
All right. Question 13. This is a repeat question again. What's question 13?
A. Alpha.
Yes, alpha. So just for working out purposes, what we're solving is 2x. In order to get rid of the modulus, we square both sides. So we're solving when 2x minus a squared is greater than x squared. It's only greater than x squared if we can expand this left-hand side to get 4x squared minus 4xa plus a squared, that's greater than x squared. We subtract x squared from both sides to get 3x squared minus 4xa plus a squared is greater than 0. We factorize it. So we have 3x, x, a and a. Gonna have to be minus and minus. And so when you reach this point now, it's just a matter of looking at how it would look on a graph. So if you were to sketch a graph, the roots would be, this would be a over 3 and this would be A. And you want the part of the graph where it is above 0. This is the line y equals 0. And you want the part where it is going to be above the line y equals 0. It's above the line y equals 0 when it's above the line y equals 0 when x is less than a over 3 and then x is greater than a. So that is A, which is alpha. Easy question. It's question 13. Question 14. So they love repeat this one, don't it?
Yes, sir.
Question 14 is beta. We just did that question. We just did that question. So question 15. It says now f of x is 3x minus 4 and f g of x is x. And so what they're telling us then is that g of x is equal to f inverse of x. That's what they're telling us, that g of x is equal to f inverse of x. And so we need to find f inverse to find g. Now f is equal to 3x minus 1. And so what we're going to do is write x.
Okay.
So interchange x and y and then make back y the subject to find the inverse. So we're going to get x plus 4 divided by 3 is equal to f inverse. And that f inverse is g. And so g of x is x plus 4 over 3. So that is beta. All right.
16 repeat.
Question 16. Yeah, we'll just do question
Delta.
16. Delta.
Right.
Question 16. That repeat. That's 2 over x minus 3. So them generous, that's a lot to be repeating. Question 17. What's question 17? Alpha. Very good, because the sine of 30 is a half. Cosine A minus the cosine of 30 times the sine of A. So that's alpha.
And 18 is delta.
Question 18.
Delta.
Delta. This is a repeat question. Yes. This is a repeat question as well. Delta. All right. Question 19. It says the relationship between the two curves. So in order to find the relationship between the two curves, we need to solve the equation of the two curves. Well, so we have x squared minus 2x plus 4, and that's y, and that's equal to 2x, because the two of them is y, and so y must equal y. So if we bring over that now, we're solving x squared minus 4x plus 4 equals 0. If we're solving this equals 0, we can factorize it. What we're going to get is x minus 2 times x minus 2. So we get x minus 2 times x minus 2. And so what we're getting is, from this, we're getting that x is equal to 2. If x is equal to 2, then y is equal to 2 times 2, which is 4. And so the point of intersection is 2, 4. That's beta. Touches the curve at 1 point. If you want, you can always sketch it too. Like, you don't need to do this in a MCQ, but just to picture it in your head, you have some curve like this. You have the line y equal to 2x, and you have some curve y equal to x squared minus 2x plus 4. So you have this, and then you have the line y equal to 2x, The line y equal 2x could look like this. How this is extending is that they only intersect at this one point. This one point is 2, 4. I know my graph would suggest that they would meet at some point right here, but this is not an accurate graph. The curve would look something more this way. Would be going something more this way. So they wouldn't actually ever meet again. Only meet at this point, 2, 4. So that's how the graph would look.
Okay. Wait.
All right, give me a second. My screen seemed to freeze right here.
Oh, okay.
All right, it's back now. Yeah, my screen just freeze for some reason.
Sir, can I get number 17, please?
17.
Ooh, help.
All right, 17 is alpha. You got that, Malik?
Yes, sir.
All right. All right, question 20. Question 20, easy. What's the answer?
Delta.
Delta. Why is it delta?
The formula for the polynomial root, is it the root?
Yeah, the
No,
secant of beta.
yeah, beta the form is supposed to be the inverse, something like that. So it turns over.
Yes, secant of beta is 1 over cosine beta.
Yes.
So it does have 1 over 5 over 13, which is 13 over 5. Easy question. So
119.
question 19. 19 is beta.
All right.
All right, question 21. What's question 21?
Delta.
Delta, agree?
Yeah, it times everything by 2.
Yes, it times the vector by 3. 3 times 3 is 9. 3 times minus 2 is negative 6. Wouldn't expect anybody to get that wrong. That would be awful.
I mean,
No, I don't know what you mean. All right, question 22. It says the curves y squared equal to x plus 7 and xy intersect at 3 points. And they want the y coordinates where they intersect. So look at this. From the first one, I can write that x is equal to, let me bring over 7, and I get x is equal to y squared minus 7. That's x. And so if I substitute this into the second equation, I get x, which is now y squared minus 7 times y squared minus 7 times y is equal to 6. And so I can write this as a cubic polynomial now to get y cubed minus 7y minus 6, and that's going to be equal to 0. So I need to be able to solve this cubic equation. First, I need to use trial and error to find a root. So I'm going to try y equal to minus 1. Y equal minus 1 I get. Yep, this works out. Y equal minus 1 I get minus 1 plus 7 minus 6, which is indeed 0. And so then now I can factorize it. Look how I'm going to factorize it now. If y equal to minus 1, then this has to be y plus 1. Then I need y and y. In order for me to get 6, it has to be 3, 2. In order for this to be minus, I need one of these to be plus and one of these to be minus. So I'm going to put minus and plus. And so therefore, y is equal to -1. Then y is equal to -2. And y is equal to 3. They only wanted the y coordinate, so you don't need to find x. So that was the reason why I made x the subject to find y. All right, because if you made y the subject, what you would have done is find x, and then after finding x, you'd have to find y. The easy way is to just make x the subject to find y. All right? So this is a new question, right? So see that this is a new question, right? You hearing me?
Will you repeat, sir?
Yeah, I was saying that this is a new question.
Oh, yeah.
Yeah, this is a new question. And I was saying that the method in order to find y is you had to make x the subject, substitute it into the other equation, and then that was it. So right here I made x the subject from this equation, then I substituted it x into this equation, and then solve for y. Easy question. So this answer is alpha. That's a new question, that's alpha. Question 23, this is a repeat question. We just did this. What's 23?
C.
Yes,
Karma.
23 is Kramer.
Kramer.
Yeah. Repeat question. Easy. Now look how them just a repeater going on. What's 24? What's 24?
Sir D.
Yeah,
Delta.
delta. We just did this question. This is another repeat. And the repeat not done this yet. Look at this now. 25. What's question 25?
Beta.
Beta. This is another repeat. See how many of them repeat from 2014 back to back to back? 3. Question 26 now. This is a repeat from 2012.
Question. Oh, beta.
Yes, it's beta. So just to work it out again, we'd have to write this as 1 plus cosine square A all square, cosine square A all square minus sine square A all square. Then we can write that now as a difference of 2 square, which is equivalent to 1 plus cos square A plus sine square A times cos square A minus sine square A. That works out to be equivalent to cos square A plus sine square A. That part is 1. And so we get 1 plus cos square A minus sine square A. But cos square A minus sine square A is 2 cos square A minus 1. And then the 1 plus the minus 1 just works out to be 2 cos square A. Easy. Soft with a capital T. So that's beta. That's 26. Question 27. This is a repeat. What's question 27?
Alpha.
alpha. This repeats so many times. It is boring to do it again. So that is alpha. All right. Question 28. Question 28 repeat from 2011.
Delta.
Delta. All right. So how did we get delta? Well, how it starts is that we know vector PQ, and vector PQ is equal to vector Q minus vector P. So it's equal to OQ minus OP. And then they want vector OQ. And so vector PQ plus vector OP is going to be equal to vector OQ. So they add OP and PQ to get OQ. So these two vectors will add them to get this one. That's vector OQ. All right, question 29. This is another repeat from 2011. What's question 29?
Alpha.
Alpha. So just to rerun again, we said let vector A be minus 6j. And so if this is vector A, then we have that the modulus of vector A is equal to 6. And then let vector B be equal to I plus j. If vector B is equal to I plus j, then what we get that the modulus of B is equal to 1 squared plus 1, which is 1 plus 1 square rooted. You get that that's equal to the square root of 2. Then the next thing we need is a dot product, which is A dot B. A dot B is going to be equal to negative 6. Well, this is really 0i. So that's the trick to it now. 0 times 1 is 0, plus minus 6 times 1 is minus 6. So plus minus 6. And so therefore, the cosine of the angle, so the cosine of theta is equal to A dot B over the modulus of A times the modulus of B. A dot B is equal to negative 6. So it works out to be negative 6 over modulus of A, which is 6, times the root of 2. And then the 6 cancels the 6 to get minus 1 over root 2. So that's alpha. Easy. Soft. All right, question 32. What's question 32? Say 1 over cosec square x.
32.
Yeah.
Wait, repeat 32, sir?
Oh, question 30, sorry.
Oh, 30, okay.
Yeah.
Yeah. Basically cross over that. Okay, karma.
All right, yes. So the reason why it is this is because 1 over cosec is sine square x. Sine square x over 1. Now, sine square x over 1, I can write that as sine square x over, remember 1 is equal to sine square plus cos square. And so 1 is equal to sine square x plus cos square x. That's it. And so we can multiply that now by cos square x over cos square x. If you multiply it by cos square x over cos square x, you get sine square over cos square. Not multiply, divide. This should be divide. If you divide it by sine square over cos square, you get tan square x. And then you divide sine in the denominator now. Sine square over cos square is also tan square. And then cos square over cos square is 1. But then tan square x plus 1 is sec square. And so that's how we end up get tan square x over sec square x. Tan square x over sec square x. So that's this one, karma. All right. All right, this question now is asking that f of x is 2x plus 1 all cubed, and it asks for f prime of 2. So first we need to find f prime of 2. So let's find f prime of 2. F prime of x is going to be equal to, we carry down the power, subtract 1 from the power, times the differential inside the bracket. So we get 3x, 3 times 2x plus 1 all square. Then we times it by 2. And so 3 times 2 is 6 times 2x plus 1 all square. That's f prime of x. That's f prime of x. And so what we need to find now is f prime of 2. So put in x as 2 now to get f prime of 2 is equal to 6 times, work it out, 2 times 2 plus 1. 2 times 2 is 4 plus 1. So that is 5 square. 5 square is 25. 25 times 6 is 150. So that is delta. Easy, soft. That's delta. Question 32.
0.
Question 32 asking for the limit as x goes to -1. What's the answer?
0.
0? Oh, you get
Yes.
0. You sure?
Yes, sir.
Why is it 0?
I think we did this already.
It is 0.
Yeah, so we imply everything is going to be indeterminate, and then you just have to find the simple.
Actually, this question, you just plug in -1. So for this question, you plug in, you get -1 square is going to be -1 square minus -1, which become +1, -2 over -1 -1. And then -1 square is 1. 1 plus 1 is 2. 2 minus 2 is 0. And so we get 0 over -2, which is 0. So we use direct substitution and we're going to get 0.
Oh, okay. I'll say something different. All right.
Yeah. This one is direct substitution. This question is a repeat. We just did this one. What's 33?
No, you don't have to tell me.
Delta.
Delta. We just did 33 in the last question. All right, question 34. Question 34 says, this is a new question, just to get this straight.
Yeah, repeat back 2019.
Yeah. So it says a dial on a plane preparing for landing registers 200 plus 5 sine h over h, where h is the height above ground. It says just as the plane lands, that means the height is going to 0. So that's when h is going to 0. When h is going to 0, the limit of sine h over h is 1.
Yeah. So
And so therefore it's going to be 200 plus 5 times 1.
it'll be
Which is
based off.
205. Because as h goes to 0, sine h over h goes to 1. So That was the trick. Well, not a trick, but that was what the question I was checking for. Easy question, right? Even though a new question, it's easy.
Not really. It was kind of challenging if you don't realize the identity rule. That's it.
Yeah. Question 35. This is a repeat from 2009, I think. So,
Yeah, it is. Even though I was in the class with you, I did the paper.
yep, repeat from way back.
Karma, yeah.
Karma, why is that? Now look at this part now. The integral from 2 to 3 plus the integral from 3 to 4 is just the integral from 2 to 4. So what they're pretty much telling you is the integral from 2 to 4 of f. And this part is now minus the integral from 3 to 4 of 1. That's just going to equal to the integral from 2 to 4 of f is 12. When you integrate 1, you just get x. And you're going from 3 to 4. And so it is 12 minus, put in 4 minus 3 in there. And you get 12 minus 1, which is 11. So that is Kramer. Question 36. Question 36, repeat. What's question 36?
Beta.
Beta. So they love to repeat this one. We're almost finished, almost there. Question 37. It gave us this curve y equal ln x, and it asks for the gradient of the curve when x is 2, the gradient of the normal. So this is a new question. So this year, look at that, they gave 9 new questions so far. This is the point where x is 2, and they don't want the tangent. This would be the tangent, only touching it at one point, but they want the gradient of the normal. So to find the gradient of the normal, we first need to find the gradient of the tangent. The gradient of the tangent is dy by dx. When you differentiate ln x, we get 1 over x. And they want it at the point where x is 2. X is 2. And so the gradient of the tangent is 1 over 2. If the gradient of the tangent is 1 over 2, then the gradient of the normal is minus 2. And so that is alpha. That's a new question here, and it is alpha. Easy, right? Easy question, right?
Sir, show here get number 35 again.
35?
Yes, sir.
All right. So let's go, but let's do it right around. Let's go to a blank screen. So they told us that the integral from 2 to 4 of f of x, integral from 2 to 4 of f of x dx, they told us that that is equal to 12, and they want us to evaluate the integral from 2 to 3 of f of x, integral from 2 to 3 of f of x, plus, put a bracket, the integral from 3 to 4 of f of x minus 1. If you're going to expand this bracket, what we pretty much are being asked is to find the integral from 2 to 3 of f of x plus the integral from 3 to 4 of f of x, and then this part, when you expand that part, you get minus the integral from 3 to 4 of 1, because that's what you get when you expand it. Now this part, now this is the real part now, this part. This part right here, the integral from 2 to 3 plus the integral from 3 to 4, that is just the integral of f of x. So this part works out to be, this is now.
Sir, how you know that?
How I know that?
Yeah.
From this principle. So remember, even when we did trapezium rule, so even with unit 2, when you're integrating, let's say this is a curve, right? And let's say this is the point A, this is the point B, and this is the point C. The integral from A to B would give you this. Integration give you area under curve, right?
Yes, sir.
And then the integral from B to C would give you this. And so what if I ask you what's the integral from A to C? The integral from A to C would be equal to the integral from A to B plus the integral from B to C. You agree? That's what
Repeat that, sir.
integration, this is what integration gives you. Look at the diagram right here. If you integrate from A to B, you get the area under the curve from A to B. Agreed?
Yes, sir.
Yeah, and so we integrate the area under the curve from A to B is this part. Right. Now the integral from B to C give you this area, right?
Mm-hmm.
Now when you add them together, the two areas, you're adding the integral from A to B plus the integral from B to C. Agreed?
Mm-hmm.
But then the integral from A to C is the same area, the total area, which will be the integral from A to B plus the integral from B to C. That makes sense now?
Mm-hmm.
All right, so that's what we did. And so this part now is just the integral from 2 to 4. And they told us that the integral from 2 to 4 was 12. So that's how we get 12 minus this part now, which is we integrate 1 to get x. And that's from 3 to 4. That makes sense? Hassan, you good now?
Yeah, I get you now, sir.
All right. So that's that question. So back to 37. 37 was alpha.
Well, left over here.
So sir, so since you can explain, well, since you have time to explain 36.
36. We want to
Repeated
do
question.
36?
Yes, sir.
All right. Let's do 36. Y is equal to the root of 2x plus 1. The only reason why I didn't do 36 was because we did it last week. So y is equal to the root of 2x plus 1. And so 2x plus 1 can be written as 2x plus 1 square rooted can be written as 2x plus 1 to the half power. And so therefore what we get now is dy by dx is equal to, carry down the power, then we subtract 1 from the power, and then we times it by the differential inside the bracket, which is 2. Now half times 2 cancel each other, and so dy by dx works out to just be this 2 cancels this 2, and it works out to be just 2x plus 1 to the negative half. That's dy by dx, 2x plus 1 to the negative half. Now let's say you don't want to use, let's say you don't want to use product rule again. Let's say you don't want to use chain rule. You can use quotient rule under this because I can rewrite dy by dx as 1 over 2x plus 1 to the half. And so now the second derivative now, d2y by dx squared is going to be equal to, you start with the bottom, Because if
Why?
it's just how I used to remember it. Imagine this, y is equal to u over v, then dy dx is v du minus u dv, but v then I bottom. And so dy by dx is to start with the bottom. So that's
And then don't
2x,
forget the back side.
2x plus 1 to the half. Start with the bottom times the differential of what's in the top, which is du. And differentiate 1, you get 0. Minus the top is just 1, times the differential of the bottom. But we already differentiated 2x plus 1 to the half. When we differentiated 2x plus 1 to the half, we got this. And so we can put plus 2x plus 1 to the minus half over the bottom square. When we square this, we just get 2x plus 1. And so d2y by dx squared works out to be 2x plus 1 to the minus half over 2x plus 1. But that's not the answer with them have. So now what we can do is multiply it. Oh wait, minus. This will be a minus sign. All right. So look at this now. We're almost finishing up. So we have d2y by dx squared is equal to minus 2x plus 1 to the minus half over 2x plus 1. So we can multiply it by, in order to get rid of this negative power, we multiply it by the same base but to the positive power of it. So we're going to multiply it by 2x plus 1 to the half, and anything we do to the numerator, we do to the denominator. So multiply denominator by 2x plus 1 to the half. Now 2x plus 1 to the half times 2x plus 1 to the minus half, when the bases are the same, we'll add the powers. And then minus a half plus a half is 0. 2x plus 1 to the 0 is 1. Anything to the 0 power is 1. So we'll just get minus 1 over 2x plus 1 times, now 2x plus 1 to the half power is the same as the square root of 2x plus 1. So that's the answer. So start from right here. We'll find the derivative of 2x plus 1 to the half, and we get this. And then we differentiate this part using quotient rule to get this. All right? So that's clear? That's clear?
Yeah, that's clear.
So that's beta. 37 alpha, we found the gradient of the normal. Question 38, it wanted the rate of, it says the rate of change of y is this. So they're telling you that this is dy by dx. So y is equal to the integral of this. So integrate 3x squared, would get 3x cubed over 3. Then we'll integrate 4 over x to the third power. Remember, 4 over x cubed can be written as 4x to the minus 3. And then we integrate that, that part is now plus 4 x to the minus 2 over minus 2. And so this works out that y is equal to x cubed. 4 over minus 2 is minus 2 times x to the minus 2. What x to the minus 2 is over x squared. When you integrate, you add some constant. And so that is x cubed minus 2 over x squared. So that is Kramer. Easy, soft. Soft with a capital T. I think this is a new question. This is a new question too, right? I haven't seen this question before. Question 39. Question 39 tells us that f double prime of x is 6x.
Yeah, we did that.
Yeah, this is a repeat. This was x
Delta.
cubed, delta. So just for those that weren't here, f double prime of x is 6x. That means that f prime of x would be equal to integrate 6x to get 3x squared plus some constant. But this constant c is 0 since f prime of c is 0. So we can just put that the constant is 0. And so f of x is then just the integral of 3x squared, which is x cubed, plus some constant c. Question 40, it says f prime of x is sine x. So what is f of x? F prime of x is sine x. Repeat.
Alpha.
Alpha. When you differentiate minus cos, you get sine, and so alpha is indeed the answer. Very good.
I'm doing that.
You have something to do in the kitchen.
Yeah, it's a go and warm up. That's it. Start the jumping. Sit down.
Question 41. It says a time t in years determine the growth of a certain country's national product. And the national product is given by this formula. It says at the beginning of the year, the gross national product was recorded as 732 million.
No, that's not count. What when I use the one?
The growth, the estimated,
No, Errol, mute your mic.
the
I
gross,
did that.
the estimated gross national product at the beginning of the year of 2000. Now, we're dealing with a time span from 1990 to 2000, right? So this is how you convert it, right? Because on a graph, we're not going to write 1990 and 2000. We're going to put t equal 1, t equal 2, stuff like that, right? So we start from 1990, and that's the initial year. So that's at time 0. And they will continue all the way up to time 2000. The time 2000 from 1990 is 10 years. It's 10 years because 1991 would be year 1, 1992 is year 2, all the way up to 2000, which is year 10. And so pretty much we're integrating from now, change 1990 to year 0. So we're integrating from 0 to 10. So looking for something with the integral from 0 to 10, which is delta. That's all we're doing. Delta is the answer. Integrating from 0 to 10. All right? Easy question. Everybody agree with why it is 0 to 10?
No, somebody go do something and come back. What we are doing?
Question 41. So as I was saying, is that 1990 is, it says at the beginning. At the beginning means when t is equal to 0. So 1990 is year 0. At the year 2000 is 10 years later. This is when t is equal to 10. And so we're integrating from 0 to 10. And so that is delta. All right? All right, question 42. It says, find the gradient of the normal to the curve at this point. Now, if y is equal to this, then we can find dy by dx. And so dy by dx is equal to 6x minus 2 And so it wanted at the point 1. So when x is equal to 1, it is just equal to 6 minus 2, which is 4. 4 is therefore the gradient of the tangent. And so the gradient of the normal is equal to minus 1 over 4. That's the gradient of the normal. Minus 1 over 4, which is alpha. All right? So that's alpha. Question 43. Question 43 asks for the total area shaded in the diagram. What's the answer? What's question 43?
Delta.
Delta? Why is it delta? Why is it delta?
Yeah, I think you have to integrate the shade, the area that you shade.
Yes, the area is that is shade, but I'm saying why you put delta? Why is it not alpha?
It's two shaded area.
To a shaded area, yeah. But why in specific delta?
I don't really know. I don't really know why.
All right, so here's why it is. Why it is delta. Delta is right. Now right here, you're going to get a positive value. You're going to get a positive value. So let's call the area for right here A1. And so the area for this curve A2, you're going to get a negative value. But area cannot be negative. The reason we're going to get a negative value right here is because it is below the x-axis. So right here, we're going to get a negative value for the area. And so overall, the integration is going to give us A1 minus A2. But that's not correct. We need A1 plus A2 to find the total area. The total area T is therefore A1 plus the modulus of minus A2. To get the modulus of minus A2 now, A1 is just the integral from 0 to 1. A1 is the integral from 0 to 1, plus minus A2 is the modulus of the integral from 1 to 3. And that's why it is delta. So again, it is delta because right here, we're going to get that the area is negative. But area cannot be negative. Area cannot be negative. Area cannot be negative. The only reason why it is negative is because it is below the x-axis. All right, so that's why we're getting a negative area. So in order to convert this area to be in a positive area, we take the modulus. All right, so that is delta. Final two questions. Question 44, repeat. What's question 44?
Comma.
1, 3, and 4.
1, 3, and 4.
Comma. Yes,
1, 3, and 4?
1, 2, and 4.
1, 2, and 4.
Yeah, C.
C.
Oh, yeah, 1, 2, and 4.
Yeah. Easy. Soft. Question 45 that repeat again from last week. What's question 45?
Beta.
Boy.
Beta. Very good. 3, 5, pi. But just for those who wanted to know how we get C for this one and how we get B for that one, let's work it out. If dy by dx is equal to 2x, then what they're telling us is that y is equal to x squared plus some constant, because when you integrate, you get a constant of integration. So let's say this constant was, I don't know, let's say this constant is 0. In the case where c is equal to 0, then the graph is y is equal to x squared. y is equal to x squared. In the case where c is equal to 1, the graph is y is equal to x squared plus 1. In the case where c is equal to -1, the graph is y is equal to x squared minus 1. So let's look at it now. Look at it now. Right here, so this is a graph of y equal to x squared. This is a graph of y equal to x squared. This would be y equal to x squared. So that one is true. That satisfies the differential equation. So we get a family of curves. Now this one is y is equal to x squared minus 1. And the first one is y is equal to x squared plus 1. And so therefore, 1, 2, and 4 satisfies the equation. And the final question, question 45, is this now. Right here we have that the radius of the circle is increasing at a rate 0.1. So they're telling you that dr by dt is equal to 0.1. And then they're asking you what is the radius of increase of the area. So they're asking for dA by dt. That's what they want, but dA by dt is equal to dA by dr times dr by dt, if we can apply chain rule. Now, area in general, area is equal to pi r squared. And so dA by dr is equal to 2 pi r times dr by dt, which is 0.1. Now they told us now r is equal to 3, because it's the instant when r is equal to 3. And so r is 3, so we get 6 pi times 0.1, and 0.1 times 6, that is just 0.6 pi. 0.6 pi is equal to 3/5 pi. And that's it. Easy, soft. All right, soft. And that's it.
See, we could do the 2 paper in one day.
Repeat. Repeat.
So we could do 2 paper in one day.
Yes, we can. That's what we're going to do from now. 2 papers in one day.
Wait, what? You said that, sorry, you said earlier said that after doing today, next week is 1 paper until we reach 2019.
You know, better do as much as I can before the time gone.
Yeah,
General.
but remember that next week.
2 a day.
You know,
Yeah, because remember, you know, we have exam. Isn't the exam the 29th?
yes, sir.
All right, so next week we'll do 2016 and 17. Then other week we can do 2018 and 2019. And then before the exam we can do the specimen paper. Just to practice all papers. We can look through the specimen paper as well.
Okay, sir.
Because trust me, the specimen paper sometimes, like I remember, I don't know if you know about the incident in 2014, but there was some paper leakage in Trinidad, and when they did it,
Trinidad
and Barbados.
Yeah, Trinidad and Barbados. When it was a leakage in Trinidad and Barbados, the paper that they gave them, about 20 questions came from the specimen paper. So I wouldn't be shocked if, given that for this pandemic, right, and we're only doing 1 paper, I don't know if they would have incorporated some specimen questions. Because the paper has been set for 2 years, but they always set 2 papers for some in case an incident happen. I don't know if the second paper would have specimen questions from it. So it's always good to do as many questions as possible, right?
Yes, sir.
So as we know it, prevention is better than cure. It's better we practice all the questions. And let's say you practice specimen and none come from it. All of them come from repeat paper from 2008 to 2019. We good same way because we do all of them, right?
Yeah.
And so anyway, we take it better with us do all the questions, be fully prepared. Then let's say I've known some persons that, because I did unit 1 in 2014, and believe me, back in high school, you had some persons that practiced all the papers up to 2012. And would you believe me not that about 20 questions repeated from 2013? And they didn't do 2013 paper. And a lot of them, they were devastated to know that they spent so many time practicing and everything came from 2013. So the point I'm saying is, let's just do the specimen just in case. You never know, right? All right, so what I'm going to do now is, yes, so as I was saying, I'm going to email, Errol, so I'm going to email you the solution as well as the paper.
The link for the
Yes,
video
and the recording, and you can forward it in the group, all right?
Yes, sir, I will.
All right, and Asani, I will send it to you personally.
Wait, you're going to send it today or tonight or
Yeah, I'm going
tomorrow?
to send it tonight.
Okay, sir.
All right.
Yes, sir.
Yeah, I'm going to send you these to your email.
Yes, sir.
All right, gents. Enjoy the rest of the evening. Don't stay up too late. And please ensure that you're all studying, all right?
Yes, sir.
And for those who have, if you did the sciences, I have MCQs all the way up, could send it. So if you have any other unit 1, MCQ
Sir,
1.
bio? Yeah, bio.
Bio, yes, I have bio. So just
All
send
right,
me
sir.
an email in the chat. Send me an email in the chat.
All right, sir.
And I'm sending the multiple choice, all right? All right, so once you send an email, I'll send you the MCQs tonight. All right, gentlemen, enjoy the rest of the evening.
Yes, sir.
Oh, sir, just remember the thing that I sent you.
Yes, I'm gonna look at it tonight.
Okay. All right, sir.
All right. Take care, gents.
All right, sir.
All right.